Okay, let's come back together with those questions and talk through them, see how you did. A great way, though, I think, to really learn the probability is to talk through them. You talk to the person in your group, and then come back together and see how we did and learn that you did them correctly, hopefully. 5A and B, we have to decide if all of these are independent or dependent events. So I always think about those old calendars that used to hang up, and you would rip out a month. We don't even use those anymore, do we? Every once in a while I'll see them. But so a month is randomly selected and ripped from the calendar, and it's destroyed, and it is July. Then a different month is randomly selected and ripped from the calendar, and it is November. Are they dependent or independent events? Dependent. Yes, dependent. I had 12 months here, then I ripped one away, which was July. I only had 11 months here left. Okay?
Oh, is it close together?
It's in the same calendar.
So the first one's
This one would be independent, but you're looking at the two events together. Looking at the two events together. Are those two events independent or dependent? Okay? So this is going to be dependent for 5. Oh, yeah, it meant to be looked at together. 6A and B, when a baby is born, it is a girl. When a second baby is born into a different family, it is also a girl. Independent. Absolutely independent. 7, when a baby is born, it is a girl. And then when a single die is rolled, the outcome is 6. Yeah, it doesn't matter if a baby is a boy or girl and what die I'm going to roll, right? Okay. When a day of the week is randomly selected, it is a Saturday. And then when a second different day of the week is randomly selected, it is Monday. Dependent. Because why? I've already selected Saturday, and it says specifically I have to select a different day. I've already taken Saturday out of my group to choose from. So it is dependent. Event B is dependent upon event A. Okay? Okay. The next group uses this chart. So pre-employment drug screening, and there's my results there. It's that same table we've seen before. And we know there's 1,000 total people that have been tested. If 2 of the 1,000 subjects are randomly selected, find the probability that both had a false positive, false positive results. And yes, my sample is so small I could probably use that rule, but as Aaron asked, they want you to see what the difference is. They want you to calculate each. So assume that 2 selections are made with replacement. With replacement. So I'm looking for false positive. So here's my false positive, and I have 90 out of 1,000. And I'm going to multiply that. And when it says with replacement, I'm going to put that person back in, right? So I still have 90 false positive out of the full 1,000. And I can choose to put 90 over 1,000 times 90 over 1,000. Isn't that the same thing as saying that to the second power? Okay? Then in part B, it says assume the selections are made without replacement. So they specifically want you to do it for each one. So it's going to be the first 90 out of 1,000, and then the next person I'm going to have how many left? 89 out of 999. Okay? And then truly the next one is the same except for that I'm using false negative results, false negative results. False negative are only 6. So I'm going to be 6 out of 1,000, and when I'm doing with replacement, it's going to be to the third power. Somebody tell me, what is that number? So doing that, is that likely or unlikely? Very unlikely, isn't it? Yeah, it's a lot less than 5%, isn't it? What does, just so we're remembering, so -7, not -4? I thought that was kind of... Just so that we have a reminder of what scientific notation means, when I have 2.16 times 10 to the -7, negative means the number is going to get smaller, isn't it? That way it helps you to remember which way the decimal goes. Okay? It's going to be smaller. I'm going to move that decimal 7 places to make the number smaller, so I'm going this way, correct? So it's going to be 0.123456216 because I started here. So 1, 2, 3, 4, 5, 6, and 7. Boy, that's very unlikely, isn't it? When you did it without replacement, you would have put 6 over 1,000 times 5 over 999 times 4 over 598. Did anybody get a decimal for that? And of course, that means it's going to be 0.1234566 zeros. And I put a 6 in there because I counted 6. 1, 2. Is that number much different from that number? Oh my gosh, it's so close, right? That's the point they're trying to make in this example. That's why they wanted you to go through those calculations to see, hey, it really doesn't matter if I treat them like independent events. I'm going to get such a small, minute difference, it's not going to matter. So I would then be able to use that rule. That's what they wanted you to see. Similarly, for the same problem again, we would be looking at true negative results. Okay, is everybody okay on that one? Good. Then we get to this redundancy. This was like the airplane that I read to you about the 3 engines. Each engine had 0.0001% chance of failing. That was a very, very small number of chance that all 3 would fail, right? So this is on disk failure, and you would lose all your data. How many of you back up your computers? You can be honest. Whew. Right. Your phone's backed up. That's the important stuff on there. Oh my. My phone's backed up too. But phone is, well, thank goodness that, because I use Android, my Google is, doesn't matter where I am, I can be on a computer, in the cloud, on my phone, it's all there. Pictures, pictures are the important things, right? And, all those text messages and my calendar. I couldn't live without my calendar. Okay. So, but the other important things, such as your tax returns that you've done on your computer. They might be important, such as papers you're writing for some class here at the college. That might be real important. When I was working on my dissertation, I would save it 4 different places. Yeah. Right now I'm writing the report for the mid-year review for the accreditation of the college. I get the lovely luck of doing the entire standard 3 for the entire college, so I'm writing. Do you think I'm going to save that in one place? Not a chance. Okay? Yeah. So think about that. Okay? So look at the difference it makes. Look at the difference it makes. First off, there is a 2% rate of disk failure. Okay? And that's in 1 year's time. If you store all of your computer data on a single hard drive, what is the probability that the drive will fail during a year? 2%. And if I write that as a decimal, it's, do you agree? Is that usual or unusual? It's unusual. It's less than 5%. But it can happen, and if it happens, oh boy, right? The old boy is too late, though, right? Okay, so if all of your computer data is stored on a hard drive with a copy stored on a second hard drive, what is the probability of both? Is both an and or an or? It's an and. It's an and of both of them failing. Being that it's an and, what am I going to do? I'm going to take 0.02, that's the probability of one failing, and times in that by 0.02. What's my answer? Right? Did I not?
0.0004.
Sorry. Okay. If you put what? 4%? No, it's not 4%. No, it's not 4%. That would be adding the 2% and the 2%. That would be adding, wouldn't it? Right. Over 100, correct. If copies of all of your computer data are stored on 3 independent hard drives, what is the probability that all 3 will fail during a year? So really, what am I doing? Raising it to the 3rd power. Yes. Yes, you can. Absolutely. And what do I get there? Did I get enough of them? 8. 1, 2, 3, 4, 5 zeros, and an 8. So if it was something important, like the stuff on your phone, right? Which one would you like to take the risk of? Yeah, right? Wow, redundancy makes a huge difference when I'm talking about something failing. You can see every time I'm multiplying by that same percentage again. Okay? Redundancy. Everybody's going to go home and back up their computers, right? Or at least flash drive something, right? Okay, this is the one, huh? This is the one. Assume that Google hires employees on the different business days of the week. So they do hiring all during the week, Monday, Tuesday, Wednesday, Thursday, Friday. Okay? And all are equally likely. So if two different employees are randomly selected, what is the probability that they were both hired on Monday? So first, I'm going to pick Amanda, and I'm going to say, Amanda, what day were you hired on? Tuesday. Was there any probability there? Because I just picked Amanda, what day, right? So there wasn't any probability to worry about. But now that I've picked Amanda, and it happens to be Tuesday, when I pick the second employee, what are the chances that that employee would therefore be hired on Tuesday? Not out of 7, it's business days, 1 out of 5. When I pick the first employee, the probability that they were hired on any of those days is 1. Because they're already there. 1. So it would be, wait a minute, did I just say that? I just said that wrong. Hold on. I was doing number B. I apologize. So that was 1 times, because I didn't read the questions, I just made the assumption of what they were. 1 times 1/5 is equal to 1/5, because the first person I choose has a 100% chance of being hired on Monday or Tuesday or Wednesday or Thursday or Friday. Okay? So if I'm saying or, what does that mean? What am I doing when I say or? Adding. So when I picked Amanda, she had a probability of 1/5 of being hired on Monday, 1/5 on Tuesday, 1/5 on Wednesday, 1/5 on Thursday, 1/5 on Friday. And if I add 5/5 together, I'm going to get 5 over 5, which is 1. Now that I've established it was a particular day, in case Amanda said Tuesday, now when I pick the next person, I've already established it has to be Tuesday. So then my chance is 1 out of 5. And 1 times any number, it's itself. Okay? That is different from part A. Part A again, I'm randomly selecting, but I want the probability they were both hired on Monday. Okay? So I'm going to choose an individual, AJ. Right now, he hasn't answered. The probability that he was actually hired on Monday is what? 1/5. So that was my first pick. Is this an independent or dependent event? Well, now I'm going to go to pick the second individual. Independent, because there's still 5 days of the week that they could have been hired. Whatever day that AJ was hired has nothing to do with the day that Vanessa was hired. Okay? So, but now I need to know Vanessa's has a chance of being hired on Monday as being 1/5 too. And it is an and situation because they both had to be hired on Monday, so of course that is equal to 1/25. Be careful with the next one. What is the probability that 10 people were all hired on the same day of the week? Did I name a day? So that first person I pick has a probability of 1, don't they? Because they had to be hired on Monday or Tuesday or Wednesday or Thursday or Friday. There's no day been selected yet. So when I do my first individual, it's 1.
So basically that first individual is left.
Yes. How many more people am I going to select? 9. I'm doing a total of 10. So I'm going to have to pick 9 more. Whatever this day came out to be, Friday. We all love Fridays. What is the probability that I pick a person and they were hired on Friday? 1/5. And I'm going to say 1/5 like that because how many times now do I have to choose individuals? 9. And I'm going to raise that to the 9th power. Which of course is 0.1234512, correct? Is that likely or unlikely? Unlikely. Much less than 5%, isn't it? Is that better?
I'm a little bit confused when you say the 5% thing, because I would imagine that 5% is so small. So if it's over 5%, is like,
It's likely. If it's less than 5%, it's unlikely. Okay? I'm missing. See, I said 5. Because I said 5, I put 5 there. 7. There we go. Very minute chance, right? Why can't it be? Why can't it be 1/5 to the 10th power? Because the first individual doesn't have 1/5 of a chance. Because they choose. Just like if I'm going to say, before I say to you, I'm doing my 10 people, I'm coming to you, have I picked a day of the week? No. So when I ask you what day of the week, it doesn't really matter what you say. There's a 100% chance you were hired between Monday and Friday. So that one's 1. Times, now that you've said you were hired on Wednesday, everybody else has a 1/5 chance of being hired on Wednesday. Okay? Okay. All right, something to think about over the weekend, right? Okay, we only got one section done, but I think that understanding is very important in this section, and I think working together like that is helpful. Do you agree? Yes. Excellent. Glad to hear it. Everybody have a great weekend.